So Marco Bosisio from
Hello, Skip.
Neptune-Benson, thanks so much for joining us. We want to introduce Marco and ask him some questions. Again, you guys have had a look at his material. Let's run around the horn here with Eric. Eric, what would you like to hear specifically from Marco?
So Marco, from the previous two presenters here, coming to you, I think we're more interested to hear when you do a reuse project, and I think even particular from the RO presentation, just the last one, you also need to consider some of pre-treatment. So I think that's one area you need to consider when you're doing different type of contamination. What's the right technology, even before you want to go to the certain RO or UV or disinfection.
Okay, thank you.
And how about Andy? Your questions for Marco.
Yeah, I concur with Eric that pretreatment is the Achilles heel of any reverse osmosis system. But I'm more interested in hearing from Marco on economies of scale. We've got a number of users on the line that may be smaller operations. You know, when do we see smaller packages versus larger packages applicable?
Okay, and Joe?
Well, I guess I'm looking forward to hearing about how you keep the flow rates up with micro sand. Being
all
smaller
right.
particles.
So, sure. We'll address these, and I think most of these the slides that I have will certainly answer most of your questions, and I'll try to address them all in details within the time frame we have, of course, Skip. And I'm certainly glad to be here with you all and ready to roll.
Okay, go ahead, and let's give Marco the screen, and it's your show. Oh.
All right, thank you. So it's certainly a pleasure. So again, my name is Marco Bosisio. I'm a VP of Industrial and Municipal Products at Neptune-Benson. And today we'll talk about but a cross-flow microsand filtration technology, specifically more in the water reuse. We'll talk about some applications at the end of that presentation, obviously. But before we focus on this specific technology, I'd like to say a few words, of course, about Neptune. For those who may not know us, since 1956, Neptune-Benson has provided different types of filtration to many different markets, municipal, industrial, and recreational. And we also have a UV disinfection system that completes our full array of products. So you're invited to take a look at our website. We have, in terms of filtration per se, we have different types of filters. As Defender, for example, the Legacy, the UV, like I talked about earlier, the ETS UV disinfection. And today, again, we'll focus on the Vortisand, which is one of our latest product that has been put forward on the market and now available for large applications, as we will see. So let's start first with the market need. I mean, in terms of water reuse, there's definitely all types of needs, and we've seen that in the presentation from Abby or Rick. I mean, there's different types of needs and water sources and water characteristics. But what comes out is often everyone, of course, wants to reduce the water consumption, looking for a minimum footprint, a minimum capital and operation cost, and obviously a maximum water quality, so to be able to reuse that water back in the process. And obviously there's ways of being green and avoid as much as possible the chemical addition. Let's see how the Vortisand technology addresses this market need. What we've seen in Abby's presentation and Rick's is that the TSS removal is very important, either to protect the membrane or into your full water treatment chain. And we've seen that in Abby's presentation. There's different ways to treat water depending on what you're looking for. But you'll notice filtration and media, using media filters, often comes up as a key feature in getting to the best water treatment chain. Or it can be a simple polishing purpose that you may have, just like rain harvesting and bringing it back to the gray water network. So we'll see these applications together. First, I'd like to show you a bit. We think there's a technological gap when it comes to media filtration. There's of course sizes of particles that we're trying to achieve and remove, either to protect your membrane, because you want a membrane, for example, on the RO, you want the RO to remove all the salt. And like Rick said, you want to remove all the suspended solids as much as possible to protect your RO. Or when it's time to use a UV reactor, you want to have a water that is very clear and allow the UV transmission to be optimized. So when we talk about multimedia filters, which is a well-known type of filters that are being used on the market, there's different types of filters, disc filters. Most of them go down to 20 micron approximately. But certainly the next step, if one wants to go further into removing these particles, either chemicals are being used, like a coagulant, a polymer, or even a full equipment like a clarifier. But there's also, of course, then the membrane at the other end of the scale that starts at 0.1 micron. And of course, then it becomes like a membrane protecting, for example, a UF protecting an RO, and there's a high cost to that. And there's definitely a gap between the 20 and the 0.1 micron. And this is exactly where the cross-flow microsand comes in, being able to filter down to sub-micron. And of course, the cutoff is always different depending on the type of solids we're facing, but it's quite a change from the typical multimedia or the media that are backwashable in the market. Of course, there's always the cartridge filters that can protect an equipment, but it's not seen as an equipment that treats per se. So let's take a look at how it impacts there's a capital cost here. Hold on, I think there's a slide missing here. Or is it? No, that's fine. It's so when it comes to cost per se, well, one may want to ask, well, how does it go? I mean, there's the multimedia, the cross-flow, and the membrane. And what we know is that typically the cross-flow microsand is very competitive to the multimedia filters. And I'm going to say especially on larger flow, like 600 or 1,000 GPM. And the membrane technologies is, of course, a little bit more costly, significantly more costly sometimes. Of course, it doesn't do the same thing either, but it is definitely very competitive on a price basis. When it comes to other characteristics, well, when it comes to footprint, the cross-flow is very fast. The cross-flow microsand, which is the vorticand, the velocity of the water through the system, through the filter, is at 20 to 25 GPM per square foot compared to a 5 typically on a multimedia filter that's trying to get the best water quality. It is typically designed at 5 or 7 GPM per square foot. So the footprint is very small, so very competitive also on the infrastructure that is needed. When it comes to chemicals, of course, there are some applications where the cross-flow may be used without even coagulants, simply because it can capture down to 1 micron and less, and that avoids sometimes using chemicals. And when it comes to the backwash water, because of the design of the system, because microsand is very easy to backwash and requires less velocity, and because of the freeboard that is designed within the system, the backwash water is minimized drastically, and we're talking sometimes up to 80% less water being used. And when it comes to energy, it's always a bit different, but everyone will agree that, of course, membrane technologies will require much more energy. Now, to compare membrane technologies to cross-flow is not necessarily fair on the energy side, of course, because it doesn't do necessarily the same thing, especially RO, of course, by which we remove, of course, the salts, which is not the case with multimedia filters or the cross-flow. Now, I'm sure the question will come how it works, so let's go ahead and take a look at that. So we have a small video here that explains here how the water comes in the system. This is an H2F model that allows to treat up to 1200 GP. But water comes in and it sweeps the surface of the media, allowing to avoid this accumulation of solids at the top surface. You remember during Rick's presentation, we talked about a cross-flow system for the membrane. We do exactly the same thing. With media that is very, very fine, we use microsand, and by doing so, we're able to use the full power of the cross-flow and being able to filter down to sub-micron particles. So, of course, the difficulty is to make sure that the sand doesn't move and the topography of the media is being kept intact. Now, of course, the question becomes, well, what happens with these particles that we trap either on the top of the vessel or inside the media? Well, they're being backwashed simply by using water. We close the inlet valve, we open the backwash valve, and just like any other multimedia filter, we backwash. But this time, notice the water leaves at the top of the filter, not through the incoming. And being at the top, it allows us to capture entrapping air, for example, or residual oil that could be floating on the top of the filter. Those also key features that clients are looking for. So maybe back to the presentation. So that gives you a brief, I guess, in a nutshell, how it works. From the outside, it looks like any other filter. Of course, in the inside, it's very different using the cross-flow process to be able to filter down so efficiently. Now, the question is, well, how come we don't use microsand in a traditional filter? Well, in a nutshell, what happens is that if you put microsand in a traditional filter, well, you're going to push the particles and trying to push it continuously on the media without a sweeping effect. It clogs the top of the microsand. It doesn't allow the particle to get in the media, and eventually there's a risk of short-circuiting fairly quickly and quick backwashes as well. So it is not, it cannot be used in traditional filters. So the idea again is to keep the particles in suspension, avoid channeling, allows penetration of particles within the microsand bed, which is, by the way, of only 8 inches. So the system is very shallow. Again, it is ideal for pre-membrane protection simply because it can go down to, again, 1 micron and less, which are often the small particles that creates these fouling. It has been shown that, for example, in cooling systems, particles below 5 micron are the ones that stick to the surfaces. So by being able to capture 5 micron particles and less without using chemicals, it's a huge feature that is available through the microsand filtration. It is obviously a very good system for the UV disinfection as it increases the water clarity and therefore the UV transmittance and increases the UV efficiency. Of course, it can also be used as a final TSS polishing. We've seen different treatment chain into Abby in Abby's presentation. So it can be used in different places where multimedia are used or disc filters are used. Again, very easy to operate. Just like any other filters, there's a few features that needs to be said. There's a minimum speed that needs to be driven through the system as you need to have that sweeping action. So there needs to be at least 40 to 50% of the design flow going in to make sure the sweeping action is always active. So it's great to retrofit. Sometimes you don't have sufficient space to increase the capacity of your plant. We can retrofit in a very small footprint. It can also sometimes avoid the clarification process if you're trying to achieve removal of very fine particles without a clarifier and the number of particles not too heavy. One thing that needs to be said also is that if you have two vorticen side by side, you can have one filter backwashing the other by using only 30% of the flow to backwash the filter that sits beside it. So that avoids the designer to build a clear well for the backwash water, which is an important feature. Again, like we said, capable of removing efficiently very fine particles and has an impact on turbidity. As we know, the turbidity is often driven by these very small particles between 1 to 15, 20 micron. These small particles have a huge impact on turbidity, which is sometimes an objective of the treatment per se. So the small backwash volume also is a key feature. There's different type. We have those small units that are vertical up to 140 GPM per single vessel. We can, of course, design different system, or many different models within a single vessel. But there's also the sorry for that. The H2F, which has been designed for 300 GPM on a single vessel up to 1200 GPM, and it can also be stacked one above the other, simply because even if it's at 300 GPM, 600, or at 1200 GPM, the unit is still 36 inches diameter. The thing, or the only dimension that changes is the length. So that allows us to stack one system above the other and have a single pre-packaged, pre-assembled system that treats 2400 GPM per GPM. So that is an important feature that the clients are looking for, especially in the industry. They want everything packaged and ready and easy to install. Again, just a few words to say that we do have a very efficient UV a reactor at Neptune, the ETS model, very efficient, and of course by combining the vorticen and the UV product, we believe we have a very competitive solution, making sure the UV will be very efficient, having, of course, clear water, and having these two systems together, we believe brings a very good product to the market. So that, you know, our system, our UV systems are NSF. They are US EPA and NSF. They follow the knee standards. We have also the NWRI ReUse guidelines, and it has been validated. So take a look at our product. This is a picture that shows also our very unique cleaning systems of our system, of our UV system. Let's go over some references and see what we have. So it could be very, very simple. It could be just, like I said, a polishing step to be able to recuperate rainwater, for example, back to the gray water network. Has been used in 2 different places, at least. These 2 are LEED references, one from the University of Montreal, École Polytechnique, the other one is University of Quebec, and has been installed a few years ago, still in operation, very robust, and being able, again, to treat particles down to 1 micron is essential, simply because the particles in the air, the average size is 2 micron, which is 10 times smaller than the typical filter will be able to grab. This one is very interesting. This one is 2 references where the vorticen H2F has been installed on cooling towers to make sure the cooling towers are efficient by making sure we remove these very small particles. Again, 2 micron is the average dust size. Being able to treat as efficiently, it allowed also the client to put a UF on the blowdown of these cooling tower and by having a clean water like this, the UF is protected and is able to bring back the water back as a makeup water to the plant. So this is a very good example of how we can be installed into a full treatment chain and protect the membrane, for example. Another one that's a brewery where the water reuse was important. So the cross-flow microsand filtration technology was chosen by this large American brewery. The idea was to bring down the ppm, or the turbidity, or the TSS, sorry, from 25 ppm down to 1 by reusing, so two streams. One was the processed water, and the other one was coming from evaporated condensate. A total flow up to 350 GPM. The water, I heard, is being used as rinse water. So I guess everyone has their own definition of rinse water, but it is being brought back to the plant, and this is a very good example of what we can do for reusing water into a plant. This one is a bit more complicated, just to show that, for example, at Electrolux in Mexico, it's a full chain from the wastewater down to back to the plant. The water is heavily charged with BOD and TSS, so they have a full chain of treatment coming from coagulation, flocculation, clarification, and then it goes to a vorticen, in fact 3 vorticen unit, activated carbon to make sure that all these soluble organics are being removed as much as possible to protect the RO membrane that has been in operation for over 5 years now without being replaced. So it does tell how the vorticen has been able to protect the membrane. I know we're running a bit out of time. I hope we're okay. And I'm ready to hear some questions or comments. Skip, I cannot hear you right now.
I'm muted.
Hello?
Yeah, the host caught himself on the mute key. Darn it. Let's go around the horn. Thanks so much, Marco. Eric, what's your first question for Marco?
Sure. Marco, I really appreciate. I do agree. The particle treatment, including suspend solid and those turbidity, is already what I think about almost a full step of the reuse project. Generally, particularly in the industry side, before you get into all this kind of high-tech treatment, particle treatment is probably the first step you need to consider it. But also, I won't be fair to ask you, Marco, what the microsand cannot handle? What kind of pollutant microsand cannot handle?
Well, it's I'm going to say obviously if a filter is put in operation in a very highly charged BOD, highly organic, where a microorganism can grow quickly, any media filter is challenged by this type of water. And of course, you cannot put it anywhere in your water treatment chain. And it needs to be installed as a polisher, not a clarifier. It's not because we can catch anything that it should be thrown in. So it's difficult to say exactly how much TSS it will handle, because it's all relevant to how much backwash you want to see. So typically we're going to say 25 ppm is fine, but it also depends, of course, on the water quality you're looking for. But we do have some system like air scouring that is available to make sure the media is always clean, even if there's some BOD in there. But I would say that if a designer believes that a regular multimedia filter or a disc filter can handle the type of effluent that is trying to be filtered, then our system will definitely take it as well.
Thank you.
Andy.
Marco, relative to the scaling, I like the fact that you've got some package systems. You've identified you can stack them. We've obviously got some industrial clients on the line that have got a very tight footprint, so we appreciate that. What sort of during the backwash cycle, are you seeing a lot of the microsand blowing out depending upon high rate, or is that fairly much contained within the system from a reuse of the media?
Of course, the design of the system needs to take into account the density of the sand, the media. So the speed at which it is backwash is important. We lose some sand during the backwash, just like any media filters, something in the vicinity of around 1 to 2% of the overall microsand, and that is per year. So we do have to top up some of the sand once per year, probably once per every 6 months, making sure that there is always a microsand on top of it. But for those designers, they know that we need to always add some sand from time to time to media filters. So it's pretty much the same thing as other filters. Did I answer your question, or?
Yeah, no, that's great. Appreciate that.
Joe, do you have one?
Yeah, I thought that was very interesting. And just two quick questions. One, is the sand really smaller than typical sand? Is it really micro sand, or is that a trade name? And secondly, does it have any applications in drinking water for turbidity removal from surface water?
Okay. Well, thank you, Joe, for your questions. In the water industry, when we talk about microsand in general, there are other applications that use microsand. As you probably know, some clarifiers do that. It's typically understood that microsand is 150 micron and less, and our system uses right now 150 micron.
Great. Go ahead. I'm sorry, Marco.
I was just going to answer the drinking water aspect of it. This system can certainly compete in water quality to any other filters that's out there in the drinking water process. For the moment, Neptune is bringing it to the industrial market simply because I think there's a little bit easier to get these projects for the moment, as municipal water treatment as a final treatment requires a lot of testing in every state. So for the moment, we're not going that direction. However, when it comes to drinking water, there's also membrane, and as a protection to membrane, we believe will be definitely in the municipal market, along with the UV, definitely.
Great. Love to ask some more questions, but we have to move along. There will be one more segment with the full panel to wrap the show up, and we'll bring all the speakers back for that final segment. But right now, we want to switch over. Thanks, panel.